Hi Year 11. Today we're going to have a look at how to find one trig function if you know another. So we'll do this through a bunch of examples. So example 1, if tan theta equals 1 on root 3 and theta is acute, find sine theta. So if theta is acute, that means we can use a right-angled triangle. And I'm just going to say that theta is that angle down in the bottom left corner. Tan theta is opposite on adjacent. So the ratio here is 1 on root 3. So I can write 1 on the opposite side and root 3 on the adjacent side. Now the reason I'm going to do this is because for sine theta, we know we need opposite on hypotenuse. So now we need to use Pythagoras to work out what the hypotenuse is. If you already remember your exact triangles, you can straight away fill in the hypotenuse. Otherwise, we know that using Pythagoras, it's going to be the square of one short side plus the square of another short side, which equals 1 plus 3 is 4, square root of 4 is 2. Just positive 2 because we're talking about lengths. We don't need plus or minus. So now sine theta is opposite on hypotenuse, which is 1 over 2. Okay, example 2. If sine theta equals negative 1 over root 2, find two possible values for cos theta. So here, sine theta is negative. Now, if you guys remember your all stations to central thing that we did yesterday, all stations to central, sine is negative in the third and fourth quadrants. So we need to find a value in the third and the fourth quadrant for cos theta. So all that means is one of them is going to be positive, one is going to be negative. To find the actual number, again, I'm going to draw a right-angled triangle. We'll draw it as though we're in the third quadrant, even though it won't really matter. We have a right angle, I'll put theta there. Again, doesn't really matter where you put theta, we're just setting this up so that we can use Pythagoras. Then sine is opposite on hypotenuse, so on the opposite side I'll put 1, on the hypotenuse I'll put root 2. And then I can use Pythagoras. Here we're going to have the square of the hypotenuse, take away the square of the shorter side, and I end up with the square root of 1, which is just 1. So, again, if you remember your exact triangles, you know that we have a 1, 1, root 2 triangle. You can just straight away put that side in. So that means cos theta, which is equal to adjacent on hypotenuse, is going to be 1 on root 2. And in the third quadrant, that's a negative value. In the fourth quadrant, that's a positive value. So I'm going to write plus or minus in front. You could also write cos theta equals 1 on root 2 or negative 1 on root 2. Those two sentences say the same thing. All right, example 3. If tan theta equals negative square root of 176 over 7 and theta is reflex, find cos theta. So again, I'm going to start by working out which quadrant I'm looking at here. So all stations to central. Tan is a negative, so that could be the second or the fourth quadrant. But we know that theta is reflex. So first quadrant is acute angles, second quadrant is obtuse angles. The reflex angles are the third and fourth quadrant, which means I'm just looking at the fourth quadrant here because that's where tan is negative and the angle is reflex. So we know that cos is going to be positive when we find its value. So to find the other value for my ratio, right-angled triangle, I'm not drawing it as though it's in the fourth quadrant. You can if you want to. but any right-angled triangle will do. Theta can go in either of the corners. Tan is opposite on adjacent. So for where I put theta, I'll just put square root of 176 and 7. And then I will work out my hypotenuse using Pythagoras. So square of one short side plus the square of the other. And I'm going to find the square root of that. That works out to be 15 when I chuck that in my calculator. If it wasn't a square number, then I would leave it as a surd. Okay, so cos theta we already worked out is going to be positive because we're talking about the fourth quadrant. Cos is adjacent, which is 7, over hypotenuse, which is 15. Okay, last example. Find cosec theta, given that cos theta is 12 over 13. So here, we're told that cos is positive. So all stations to central, cos is positive in the first and the fourth quadrants. And now cosec is the reciprocal of sine. So I'm going to work out sine theta first and then cosec theta. So here, again, any right-angled triangle will do. You can put theta wherever you want. And cos theta is adjacent on hypotenuse. So on the adjacent side, I'll put 12. On the hypotenuse, I'll put 13. And then if you know your Pythagorean triads, you know that the other side's going to be 5. If you don't, just do square root of 13 squared, take away 12 squared. So sine theta here is opposite on hypotenuse, so 5 over 13. But we're talking about the first and the fourth quadrants. So in the first quadrant, sine is positive. In the fourth quadrant, sine is negative. So I need to put a plus or minus because there are two possible values here. Then cosec theta is the reciprocal. So cosec theta is plus or minus 13 over 5. And that's our final answer there.